Because I keep forgetting to do attendance in here. What? I am all tangled up. Oh, that's very elementary. To be drumming on the desk like that? Oh. Or it's very 2000s, because that was everything in the 2000s. Alright. Okay. Alright. I saw him earlier today. I was like, Brian, I saw him earlier today. But he not in here. Alright. So today we are going to look through chapters 8 and 3. Because this is the order we did it. So we did 1, 2, then 8, then 3. And that'll get us to the end of first semester. So today we're finishing out everything that was last semester. 4, 5, 6, 7 are the things we did this semester. So we'll do those tomorrow and Thursday. Y'all okay? Okay. Breathe. We'll be all right. All right. So we'll do this one tomorrow. Let's look at page number 2. Both of these are chapter 3. And it's all about units and unit scales. And one thing I want to point out that I didn't point out yesterday, we do not get a reference page that you get to use on the final. You will be given these exact formulas in this exact order. This is a direct clip from the final onto the review. So all these ones that are listed under the important formulas, including the important formulas heading, these are a screenshot, these are a clip from what we have. And as we get through using them, we'll talk about what they are and why we need them and all that jazz. But these are the ones we get. So you don't get a reference page, but you do get these. Okay, so just to clarify that. So looking at question number 3, we're building a patio on your house, and the blueprint uses a scale of 1 to 36. What that means is 1 inch on the drawing is 36 inches in real life. That's what that means. So 1 inch on the drawing is 36 inches. I'm just going to put IRL because I feel like you guys know what IRL stands for because you're not 50. So if the picture is 3 inches by 4 1/3 inches. So my picture shows 3 inches by 4 1/3 inches. What would this be as an in real life measurement? If every 1 inch stands for 36 inches. How could we find that out? 36 times 3. Because there's 3 of them. So this 1 inch is 36 inches, this 1 inch is 36 inches, and this 1 inch is 36 inches. So I have 3 sets of 36 inches. So, and that calculator is dead. So that 3 inch side is going to stand for how many in real life inches? How far will this side of my patio be in real life? Yeah. 108 inches, which we usually abbreviate with 2 little lines. How about the 4 1/3 side? How'd you figure that out?
4 1/3 times 36.
Yeah.
I did it right.
Yep. So you can put 4 1/3 times 36 in the calculator. You could also do 4 times 36 divided by 3 plus, or 4 times 36 plus 1 divided by 3. Like, it's a whole thing. You could do it as a unit change and get this to be a mixed number or an improper fraction and do it that way would be the easy way to do it. Either way, we should wind up at 156. 1/3 of 36 inches is 12 inches. 4 times 36 plus 12 would be a way to do it. Like, there are many, 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 many pathways through it. Somebody's music's really loud. Please turn it down. So our dimensions in real life are 108 inches by 156 inches, which I'm 100% okay with us leaving like that. We don't have to put it in terms of feet. You absolutely can. In which case we would take each of these and divide them by 12, which is going to be 13 feet and 9 feet. These things are equally correct. So you can say that it's 108 by 156, or you can say that it's 9 feet by 13 feet. Those are equal amounts of correct. Okay, those are both valid. One of them is going to make it easier for part B, because then we're going to talk about the flooring. So we're trying to put floor on this patio, and it costs $4.75 per square foot, which means what we need to know is we need to know our area of the patio, ideally in square feet. So how do we find the area of this rectangular patio? How do I find the area? Length times width, multiply them. Yes, you're both right. So we're going to take our 9 times our 13. Since we want this to be square feet, it's going to be easiest if we use feet. So I want to use feet so that I don't have to do a unit conversion upon a squared thing, because squared things are gross to convert. So take our inches and make them feet, inches and make them feet, so that I can find my area in already square feet. Because 9 times 13 means our area is 117 square feet. If my flooring costs $4.75 per square foot, how can I find the cost of the floor? 117 times 4.75. Because my $4.75 per square foot times my 117, that's not a T, feet squared. You can do it this way and set it up like we did unit conversions back in the last chapter, or in the last semester, where my feet squared cancel out and we're left with our 475 times our 117, and we get, the only unit left is dollars, 555 and 75 cents. So for my patio, I can find out the cost of the flooring just from the picture and the price. Questions on any of these pieces? I felt like we kind of jumped all over the place on this one. Okay.
Can you write in darker color?
Oh yeah, the pink one. Yep, I will change that out right now so I don't use it again. The 9 and 13 came from taking my 108 inches and dividing it by 12 to make it feet. So I took 108 and divided by 12 because there's 12 inches in a foot. So I took this and we divided by 12. Or you can do it as a unit conversion. I can do it 108 inches. And there's 1 foot per 12 inches. You can set it up this way. And that'll give us that my inches cancel out. 108 divided by 12 gives me 9 feet. And I will also change my light blue out for a darker color. There we go. Okay, good questions, guys, good questions. So there's a few different ways to work your way through this. There are a few. But I think going from drawing to inches, inches to feet, feet to area, area to cost is going to be the easiest kind of direct way through. Just because we're dressed like middle schoolers doesn't mean we need to whisper like them. Jadian. Just because we're dressed like middle schoolers doesn't mean we need to whisper like them. All right, so let's look at number 3. It's very, very reminiscent of our, if we look up there, our Hop Like a Frog stuff. If you remember when we did the storybook time last semester, and we read a story, and we hopped like a frog. Yeah, I know, you missed out on story time, sorry.
Oh,
Huh?
that happens?
Yeah. Like, yeah. It will be after kind of go through it. Like, we for real sat down and read a story.
If you hop,
We did really did.
I will, yeah.
oh,
This is from that same thing. It's all those things that we did up there. We made little posters proving whether or not the claims in the book were true. Like, we did a whole thing with it. So this is very much based off that. So if a human could hop like a flea is what we're looking at here. So we've got fleas are about 0.1 inches and they jump 35 inches. So we want to know if a human could hop like a flea, if they would be able to get over the Willis Tower in Chicago. So we're looking at comparing some ratios here. So there's a few different ways to do this. And it's been a minute. So I want you guys to think through this one for a second, because it has been a minute, and this is one of the harder questions. And honestly, this is one that tends to trip people up. So I want you to think it for a second and see what we think about. What is something we could do?
Divide 0.1. So 35.
You could. You're going to get a gross decimal. If you flip the other way, it's going to give you a significantly nicer number. So I'm going to start with just by looking at my flea. My fleas can jump, I'm going to write it like this, 35 inches. And the flea is 0.1 inches. So at least they're in the same unit. So the inches are going to cancel out. So fleas jump, if we simplify this, how much of their height? 350 times their height. So then we're going to look here at Wesley, who is an adult male who's 5'11". And I want to know if he could jump like a flea. So if he could jump 350 times his height, would he make it over the Sears Tower, Willis Tower? I cannot correct it. It has been the Sears Tower since I was a child, and I cannot fix it. So it might help to pick a unit. You can either write Wesley's height as feet and make our 11 inches be a decimal. It's not 0.11. Or we can switch it to be inches. Either way is fine. I'm going to say inches is probably easier because it's less decimals. Yes, I know. I was looking at your class when I changed all the names in this freaking review. Chill. It's all your friends from Algebra 2 that are filling up this review. I know. I definitely don't use my class rosters to help pick me names for story problems. I was gonna say pretty much all the names in this. That's how I either pick a class roster or I'll pick a TV show. But usually on a review, I need more names than a TV show will give me. All right. So you were not special. What's up?
Oh, so how did you get 350?
We did 0.3, or we did 35 divided by 0.1.
Oh, that's 35?
That is a 35.
I thought that was
No, that came from this piece up here, right here. From the fleas jump on average 35 inches. So I'm going to take Wesley and I'm going to get him out of this mixed number, my 5'11". And I want to make that be inches. So we can take my 5 feet times 12 gives me 60 inches. Plus 11 means he's 71 inches tall. Now, if he could jump 350 times his height, how far would he jump?
24,850.
How did we do that?
71 times. Oh wait.
Yep.
Yeah, 71 times 350.
71 times 350 means he would get 24,850 inches if he could jump like a flea. Is that taller than the Willis Tower? I don't know, because they're in different units. Because this is in inches. What do I do to get my inches to be back to feet? Divide it by 12. Since we did a lot of unit conversion in chapter 3 and it's been a minute since we got there. So we're going to take our 24,850, I'm good at writing numbers, inches, and we're going to do it, I'm going to write it as a unit conversion here, where we have 1 foot and 12 inches. So my inches cancel out. We take our 24,850 and divide it by 12. And we get he would be jumping 2,070 feet, 0.8, and some change. So would he make it over the Willis Tower?
Yeah.
Yes. So that would be our answer, and then our justify is he can jump 2,000 feet. That's more than 1,000, or more than 1,450. And he would even have a lot of wiggle room. He'd have like 500 feet. What are you whispering about now, JDon? Uh-huh. Questions on these two? Chapter 3 was a lot of unit conversion stuff. Okay. What's up, Giggles? I am moderately concerned about the sheer amount of giggling coming from the two of you. All right. Oh, here's a number 8. Here's a chapter 8, and then a chapter 3 right behind it. So number 10 is our next one that we're going to do today, because we're just doing chapters 3 and 8. So I'm trying to keep things contained. Chapter 8 was our statistics chapter. It's how we, we're way back at the beginning of the year. And we don't have tons of stats on this test. Like, there's not a ton of it. But this uses some of those words. So you're trying to decide what college to attend by using the average graduate salary. So that we have here that Hatching University has a mean salary of $45,000 with a standard deviation of 1,000. And then we have Sluggington College has a mean of 47,000 and a standard deviation of 6,000. we need to use both mean and standard deviation. So just looking at these two values, we see that Sluggington has a higher mean. I would love to have a higher salary. That's great. However, we have to remember what that standard deviation means. Does anyone remember what our standard deviation is? Did you just say yup or nope? I was going to say I couldn't tell. All I heard was the up. Okay. So what the standard deviation is how far from the mean for most. So for Hatchings University, we have our average of 45,000. I'm just going to say 45K. And most people are within 1,000 this direction, so down to 44, or 1,000 this way, up to 46. So most people are in this range somewhere, between 44 and 46. That's not too shabby. Sluggington, if I did the same thing with that, our mean is 47, so it's a little bit higher of an average. Their standard deviation is 6,000, so to catch most people, we have to go out 6,000 down to 41, or up 6,000 to 53. So it has a much wider range. And when we're looking at these kinds of problems, especially when I'm asking you why, and it's a standard deviation kind of problem, there is not one right answer. It's about your justification. Because yeah, Sluggington is going to give you a higher possibility. 53K is included in its standard deviation. However, Hatching is going to be more evenly spread out. Like you are not going to go as low. I guarantee I'm getting at least 44. What's up?
So standard deviation is basically just how much it goes forward and backwards?
From the mean, yes. And that catches most is the way we talk about it. It is a literal majority. That's 2/3 of the answers. I don't care if we work that in. If we include the fact that Hatching's average salary goes between 44 and 46, where Sluggington's goes between 41 and 43. Even though Sluggington has a higher mean, you have a risk of going lower. What's up? Yeah, how are you? So it's a matter of opinion, and there are legitimate reasons to choose both. With Hatching, we're guaranteed, or we're almost guaranteed a higher rate. Like, I'm not going to go below 44. It's giving me at least 44. Whereas Sluggington, it's more of a gamble, but we're gambling for higher as well. So it's an opinion. But the mean being the middle, and our standard deviation is all about how far from the middle it goes. Okay? I know it's been a hot minute since we talked standard deviation. And you are not going to have to calculate it. This is back when we did with the Code App software, and we were working with all the little dots and all the little things that we did and our little projects, and it was really kind of fun. And I am in love with that software, but that was new this year. Okay? So on these ones that are opinions, include your reasons, because that's what I'm looking at. I'm looking at your reasons and your logic. So then we're going to look at number 11. That's our next one. We're going to write expressions that will convert days to weeks. So if I gave you some number of days, how could I convert that to be weeks? So if I told you it was 21 days, how would we convert that to weeks?
X divided by 7.
Yeah, because if it was 21 days, we know that's 3 weeks because we're dividing it by 7. So we take the number of days and we divide it by 7. So when in doubt, give yourself a thing to think about it. So my first thought was, well, 2 days. Well, that's harder to think of, so let's go more. 14 days. 12 days. Think of a bigger number and we can help convert it in our heads, and that'll help us come up with the little phrase for it. How about hours to days? If I give you some number of hours, like say 48 hours, how would I convert that to be days?
Divided by 12.
Divide by
Or 20.
24, because there's 24 hours in a day. I was gonna say you gave me half days. That's a thing. How about years to days? If I told you it was 2 years, how many days is that gonna be?
365.
Years times 365. There we go, 365. So then it starts to get a little wonky here. Hours to years. So if I give you some number of hours, how could I convert that to years?
600.
That you're thinking minutes. I was gonna say, I saw where you went, but that's minutes in a year.
Is it just 525?
That's minutes in a year. 525,600 minutes.
8,716.
Minutes. How are you getting that?
365 times 24.
So we're taking our hours and dividing it by 24 to get it in days. And then we're taking our days and dividing it by 365 to get to hours. So you can think of it like this and do it combined. You can do our hours to 24 in a day. Hang on, I'm going to write this as 3 separate things. There we go. 1 day is 24 hours. And 1 year is 365 days. So when we're looking to simplify it, my hours cancels out and my days cancels out, and we're left with whatever our number of hours that they gave us divided by 24 times 365. And like, that's enough. You don't have to multiply it together. You absolutely can. We know how to type things in a calculator because we're super duper awesome like that. Where we have our 24 times 365. And it's going to be H over 8,760. But honestly, that's, I think, the hardest one right there. Okay. That one's definitely the hardest one. So let's switch it back to easy mode. How do I convert minutes to hours? Minutes divided by 60, because there's 60 minutes in an hour. How about hours to minutes? If I give you hours, how do we figure out how many minutes that is? Multiply it by 60. So it is important which way it goes. Minutes to hours is different than hours to minutes. Questions on either of those? And I don't think we have many more, because we've done all of that. That's chapter 4. We'll do that one tomorrow. 2, 5. There's a 3. Number 18. It's a scale question. So it's very similar to our when we had the patio. But this time we have 0.75 inches. So 3/4 of an inch represents 90 miles, like on a map. So how many miles does 1 inch represent? Is it going to be less or is it going to be more? If 3/4 of an inch represents 90 miles, it's got to be more. So does 60 make sense?
Are you talking about compared to 1 inch?
Mm-hmm.
I don't get
Is
the
60
question.
more than 90?
Oh, okay. I get it.
Okay. Because 3/4 of an inch is less than 1 inch. So 90 can't be less than. So the kind of easiest way to set this up would be to take my 90 miles over my 0.75 inches. And if we put this in a calculator, that's going to give us over 1. It's simplifying it to be over 1. So if we do 90 divided by 0.75, how many miles are represented by 1 inch? What is 90 divided by 0.75?
120.
120. So it's 120. And we can do that just by typing those into the calculator. The calculator is always simplifying it to be over 1. Every single time. So miles to 1 inch is going to be 120. Because I wanted miles per 1 inch. So if I want inches to mile, what we're going to do is we're just going to flip it upside down. I want to know if 0.75 inches represents 90 miles. I want to know how many inches are going to be 1 mile. So we're going to flip it upside down.
0.0083.
0.0083. And it's very similar. We're just typing it in the calculator. 0.0083 inches. And this one was miles. I'm just going to put my units in there. How many miles are shown in 2 inches?
24.
How do we know that?
Doubling the 1 inch.
Doubling the 1 inch. If 1 mile is 120, or 1 inch is 120 miles, 2 inches is 240 miles. And then we want to know how many inches in 900 miles. How could we find that out? Super close, super close. So you can think of it like that, where we have 900 miles. And we know it goes by a similar ratio. So it's going to have the same kind of ratio where we have our 90 miles to 0.75 inches. And you could set this up as an X, and you could do like a cross multiply situation. That is a valid strategy here. We could also take a super close look here. What do I notice about 90 and 900? Yeah. So to get from here to here, you can times by 10. So what could I do from here to here?
7.5.
Times 10. 7.5. It was trying to get us to see a pattern, but it's not the only way through. You could do a cross multiply. You could take your 900 and divide it by 100 or 120, because it's 120 miles per inch. So you could do that way. There are many, many ways through it. It was trying to get us to see the pattern, but that doesn't have to be the only way we do it.
I got I did 0.0083 times 900, and I got 7.47.
It's because there was some rounding when it came to doing it the inches per mile. We rounded just a little. And it would get you close enough, and honestly, I'd take it. Because you went the hard way. All right, I think that is it for 3 and 8. Okay, so we'll go through 4 and 5 tomorrow. Just flipping through again to make sure I didn't miss any. It's 2:15. So it took us a little while to get through that today, but I wanted to make sure we got through what we needed to get through. Okay?